I can see it.
I can see it.
Okay, Jalen, look for something that says, I'll try to stop or try to well, I guess you can't refresh your screen, huh? Can you still not see it, Jalen? Jalen, you there?
No, I still. It's probably just because my Wi-Fi being slow.
Okay, you can pull it up on the Schoology if you want. It's the motion notes or something like that. And we're on a slide that says motion graphs and it says distance time graphs, and then in red it says speed time graph.
All right.
All right. So the big thing is on the x-axis, it'll always be time. Okay. So the big thing is making sure, so if you want to make a note, always look at your y-axis. That's what I want you to write a note about. Always look at your y-axis. Okay. Because that kind of helps us determine from there what's actually happening on the graph. So the first thing that you want to make a note is always look at your y-axis. Okay. All right. Because otherwise the graphs look exactly alike. But I think once we go through these in practice, you're going to be like, oh, these are easy as long as you look at your y-axis. Okay. All right. So I'm going to go to the next slide. So Jalen, we're on a slide that says distance time graphs. Okay. All right. So if we're looking at this, we're going to go not fast through these, but just want to, I think you guys, we already kind of did this. So when we look at time over distance, which one of our formulas uses time and distance? We got speed or acceleration. Which one?
Speed.
Speed, right? So this is going to tell us the speed. So time is always down here. Distance is always on the y-axis. So the further up you go, the more distance you travel, the further to the right you go, the more time is taken. That's kind of standard, okay? All right, remember I'll tell you if you need to really write something down. Now, if you see this line, right? This is time versus distance, and your distance isn't changing, are you moving? No, you're not moving, right? Does that make sense? If my distance isn't changing, but time is continuing, I'm sitting here, time is going on, 1 minute, 2 minutes, 3 minutes, I'm not moving. So anytime you see a distance time graph and there's a straight part of the line, you can say it's at rest or it means it's not moving, okay? So if you see a distance time graph, straight line, on this graph means it's not moving, okay? Now, when we go to another graph, if this isn't distance, it's moving, but it's moving at a constant speed. And we'll get to that and you'll see the difference in a second, okay? But if you have a distance, the important thing to look at is this y-axis, okay? So this is the distance. My distance is not changing, but time is, I am not moving. Everybody understand that? That makes sense, right? Okay, all right. Now here, okay, still distance time. It is moving, okay, and notice this line is pretty straight. And what I mean by straight is it's not going like, it's not like curving or anything like this. So this object is moving and the speed is constant, okay? I'm going 50 miles per hour, 25 miles per hour, 85 miles per hour. It's constant. I'm not going 50 miles per hour and then speeding up and slowing down. The speed is constant. So anytime you see a straight line, okay, this means this is a constant speed, okay? All right, now let's talk about the difference between how those lines look, okay? So this says both of the lines in this graph show that the object moved the same distance, right? Because if I look across here, the distance is the same, okay? But the time isn't, okay? So this one's steeper, all right? So if you thought someone was moving faster, which one do you think would be moving faster, the dashed line or the solid line?
The dash.
The dashed line, right? Look, they're getting to the same place as this line, but in a shorter amount of time, right? If this is hours down here, they got to the same spot because this and this are at the same spot in terms of distance, but this one got here way faster. So it must be moving faster, okay? So this is, they're both moving at a constant speed, but I don't know, maybe this one's moving at, I don't know, 50 miles per hour, and maybe this one's moving at 70. Okay, so this one, the steeper the line, and when I say steeper, I mean going more towards standing straight up, that means it's moving faster. And you guys tell me if I'm moving too fast, okay? All right, if you see a line like this, okay, so this isn't a constant speed, right? Because this line's kind of like gradually getting steeper and steeper and steeper, okay? This means it is accelerating, okay? So what it means is, imagine you are driving in a car, okay? And you get ready to get on interstate. So let's say you're going down the ramp. When you initially get on that ramp, are you going 80 miles per hour? Yes. No, right? You gradually accelerate. So this is like getting onto a ramp to get on interstate. So I'm at a red light, I get on, and the closer I get to merging into interstate, I got to speed up in order to be able to catch up with traffic. Okay, so here I am increasing in speed, and then I'm accelerating. Okay, so increasing in speed is accelerating. All right, I feel like I'm flying through this, but have I just, remember you have those slow down buttons, you can clap, give me a thumbs up, whatever, to let me know that I need to slow down. Everybody feel okay right now though? Okay. All right. Now, we did this the other day a little bit when we were talking about finding the velocity or speed of a line. We did remember we had the two plots, we had the XY plot, okay? If you want to write this down, this is a good formula to have, okay? Rise over run, okay? Remember we had the two addresses, right? So the address for one plot was XY, and then the plot for the other address was XY, okay? So let's write down rise over run. So this is the address of the second point, whichever one is higher, and this is the address of the first point, okay? So get that down. And then if you want to make a note, the 2 is for the second point. So the point that's further out. Okay, the point that's further out. All right. So X and Y1 would be for the point that is closer to the origin of 2, 0. Okay, so it would be like down closer to here, and the X2, Y2 would be whichever one is further out. Okay, oh, sorry. Anybody still writing on this one? Okay, so let's see, let's get into some practice problems. So for instance, can somebody, so remember when you're doing got a question? Sorry, oh, I'm sorry.
Yeah, I was gonna ask if you, yeah, I needed to write that real quick.
Okay, sorry.
All right, I'm done.
Okay, so I'm gonna, the only part that's hard is I can't, oh wait. Oh yay, okay. All right, so let's look. So on here, if they wanted to know the velocity of the line, here's the cool thing. You have, I'm gonna see if I can use, okay. You have points, you've got a point here, 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 and here. And you really could do anything on this line. So as long as you do 2 points, it really doesn't matter which ones you do, you should get the same answer. So if your line goes all the way down to 0, that's an easy one, right? It's 0, 0. So that's an easy one to use. But it really doesn't matter if you use like this point and this point, or this one and this one, or this one and this one. It really doesn't matter. If you have a point and it goes all the way to the origin though, down here, use that because that's 0, 0. That's an easy one. But for example, I usually try to do one that I can read pretty good, but this is pretty easy. I can see that this one is at 10 and 20. This one looks like it's at 15 and 30. And then this one looks like it's at 20 and 40. So for example, let me see if I can write on here. All right. So we said it was Y. Is it gonna let me write? Pen. All right, so let's see if I can, oh wait. No. All right, I'm gonna see if I can share my screen for a second and show you how I would do this. I guess I'll just do a blank sheet of paper. All right, so if I were to look at that, so can you guys, so just remember what this looks like. Let me see if I can screenshot this. I'm gonna try. Let's see. Do people feel okay with finding slope? I'll do one just in case.
Y equals mx plus b, right?
I'm sorry, I'm sorry, rise over run. So let's see if I can screenshot this. Oh, you know what? I bet I can do it right here. Let's see. I'm just gonna do a big box. All right, so I got this, okay? Can you guys see? No, you can't. So let me see if I can share that. Oops. Let's share this for a second. All right, so if I'm looking at this, don't mind my writing, it's gonna be rough, okay? So as long as I have two plots, so let's do, I'm gonna do this one and this one first, okay? So those are easy. So remember your coordinates are X and Y. So remember the formula you wrote down. So there's a XY here and there's a XY here. And if you can do this one, if it goes to 0, 0, that one's always easy because this is 0 and this is 0. Now, is this my X and Y 1 or my X and Y 2?
1.
1, very nice. So, and which one goes on top, Y's or X's?
Y's.
Y's. Okay. So on this one, my Y is 40. So 40 minus my Y down here, which is 0. Divided by my X is 20. 20 minus 0. So that's 40 over 20. 40 divided by 20 is 2. Is that right? That seem right to you guys? Okay. So let me do another point just to show you it'd be the same thing. Let's do this one and this one. So in the blue, my X here is 15 and my Y is 30. And down here, my X is 5 and my Y is 10. So if I did these, my Y's first, 30 minus 10. And then my X's are 15 minus 5. So let's see if we still get, that doesn't look right, does it? Did I do that wrong? 15 minus 5. Oh yeah, that's right. Okay. 30 minus 10 is what? 20?
20.
15 minus 5 is 10. And if I divide those, I still get 2. Okay? So does that make sense? It really doesn't matter what set of points you use, just as long as you put them in the right spot. As long as you do your Y's on top and your X's on the bottom. And you make sure you do the one that's further out first, because otherwise you're going to get some negative numbers. All right, questions on how to find speed. Oh my goodness, class is almost over. Okay, let me get to one more slide. Let me see. Share screen again. Jalen, we were doing that slide that said, what is the velocity of this line? All right, let's see. Oh, look, it was already on there. I forgot. All right, so let's talk about just a summary. So here, okay, and then we'll stop here. This line, really straight up, it's almost standing completely up. This is a really, really fast, steady speed, okay? Here, this line is increase, is a steady speed. Steady means constant, is not changing. And then for a second, it was not moving. Then he started to decrease in speed. And this one shows an acceleration. So it's gradually, it's getting on interstate. It's gradually getting faster, okay? Any questions on this? All right, we're gonna stop here for now because class is over. If you did not finish your quiz or start it, I will get that started for you guys. I'm gonna put this video up and then we're gonna continue this on Tuesday, okay? All right, if you still need help with the quiz, stick around for a second so I can make sure I open it back up. And I'll see you guys on Tuesday.
Bye.
Bye, see ya.